Well, chapter 8, section 3, last example, example 7. And I kind of joked around at the far side before with trying to get into heaven, and then Larson tried to cover both ends of this deal. So if you end up in hell, that's what he was saying, you'd have this library of word problems, story problems you'd have to deal with. So um, hopefully you don't feel that bad about these. If you're getting the systems down and how to do writing equations and translation, the translation part is the tough part in this. So let's look at this. Probably as about as complicated as they get is when you have airplanes traveling. You have a lot of air speed issues compared to ground speed, and it's because you're either flying with the wind or against the wind, and you can get into a lot of geometry if um, which is more typical because you're usually not flying directly against the wind or directly with the wind. It's an angle thing. But you can calculate through vectors, and in physics you can actually calculate to figure out what the actual headwind or how much force you're having to fly directly into and stuff like that is more of it. So navigators in these airplanes hopefully have all that figured out. Well, in this case, again, we want to our main strategy to solve these kinds of word problems is to create equations. So, and they do another type of familiarize again, and don't confuse that with, hey, let's just guess and check and see if we can get close, because it's pretty difficult in most cases. They kind of the examples they come out with whole numbers and stuff like that. If I wanted to give you a test question, like I said before, that involves maybe just giving me the correct answers, but if I throw fractional stuff in there, it would be almost impossible to guess and check. So, one of the reasons one of the reasons that we actually ask for the equations too is we want to see that you're using the correct method. Well, let's go through this. There's a Boeing 747 400, I guess that's a type of 747. Jet flies 4 hours west with a 60-mile-an-hour tailwind. Tailwind means that it's going with the airplane, so it will add that amount of speed to the airplane's actual ground speed. And when we're talking about how the distance is traveled, they're talking about really, like from one city to the other city if we were traveling on the ground. And returning, it's basically they're assuming the speed of the wind is exactly the same, and we're going to fly, when we return, we're going to fly going against that 60 mile an hour, something called a headwind. So it's going to slow down the airplane by 60 miles per hour, and which would, kind of indicates by the time it takes. The distance stays the same. I mean, it's from one location to the other and then back from that location to your beginning location. So returning against the wind takes longer, 5 hours. They want us to find the speed of the jet with no wind. So to familiarize, we imagine the situation. You make a drawing of this thing too, and it's probably a good idea, and then start writing some notes along that. I don't think you have to draw the actual airplanes, but you need to note probably in the drawing, when I go from one location, from this location to this location, which is with a tailwind, because they're showing the wind is going this way, the distance I actually go is exactly the same both ways. So I'm going to say d is the distance, and we got a rate times time problem again still. So we need to think about those different formulas in the way that we may need them. Then they say, well, if I went with a tailwind, it's going to be whatever this rate is. What are they looking for? They're looking for the speed of the jet without any wind. So that rate we'll call R. Now if I put the tailwind with the rate of the plane, it's going to add that 60 to it. And then we also know the time, and we know distance is this d, right? Well, when it goes the other way, the rate of the plane is going to go against that 60 mile an hour wind, so it's going to subtract from the speed. And they're talking about a 60 mile an hour wind again. We know this new time, which is longer, 5 hours, but the distance is going to be the same d. Now, I think a lot of you will be able to write from this information. You'll be able to see how to write your equations by using the rate formula. You know, we could say d equals rate times time, right? So you might be able, a lot of you are going to say, well, here's my rate, really is this r plus 60, and then I take that times this algebraic expression times 4, and that's going to equal my distance. When I go the other way, the distance is the same, and it's going to be this rate times this new time of 5, and they're both equal to d. Now, to make sure, they basically say, well, let's put an actual rate in and see what happens. And it's really about guessing and checking. Is about, do I really understand how to figure out what's going on with these rates? And this is probably the part here, is that this is the tough part, is to catch that, hey, I got this plus 60 and this minus 60. But if we actually guessed and say, let's say the jet is going 400 miles per hour. Well, when it goes with the wind, how fast is it really going on the ground? Well, it's going to be 400 plus that 60, which then hopefully you'll see, hey, that's how I get that expression. When it's going against the wind, that speed's going to be subtracted, so I'll be going through 340 miles per hour. And then they throw that in there and say, well, if this worked, let's say if it was truly 400, well, the distance with the wind would be, for 4 hours, would be 1,840 miles. And the distance against the wind would be 340 times 5 is 1,700. Well, you know, it was kind of close, but that isn't exactly the same distance, so we know these numbers aren't right. So we want to write the equations, basically, and here's that table that tells us I take distance times rate, or excuse me, distance equals rate times time, and we write that same equation just with this different times and different rates right here. So we get these two equations, and again, this is a good candidate for substitution since it's already solved for a variable distance. So they substitute in r minus 60 times 5 for d up here, and you could do that either way, but you know, it'd just be the inverse or the reflection of this, right? Make sure you distribute, so we get 5 times r minus or plus 5 times negative 60, which is a negative 300. Here we get 4 times r is 4r, plus 4 times 60 is 240. And then they solve this equation. If you add a negative 4r to both sides and a positive 300 to both sides, you're going to get r equals 540. So what is this r? What does that mean? You got to remember, what is this r we defined it as? Well, this is the rate of the jet without any wind. So if I want to test this thing to see if I check it really, if the plane speed is 540, when it goes with the wind, the actual ground speed is 600. So if it goes for 4 hours at 600 miles per hour, it's going to go 2,400 miles. If I go against the wind, it's going to be 540 minus that 60, which is 480 miles per hour. But in this case, the travel time is 5. And when I take 480 times 5, I get 2,400 miles. Now that means that this works, is that with that rate of speed for the jet, I will go the same distance just in a different amount of time with that headwind or tailwind. So then make sure you answer the question. You know, the speed of the jet with no wind, that's what they were looking for, is 540 miles per hour. Now they just give a box here with some tips. Now these, going through all of these 7 examples, covers most of what you're going to run into in your homework and any quizzes or tests that we're going to run into. But these are really nice. Again, this is pretty close to some of the strategies we've talked about for all word problems. But first it says draw a diagram using arrows or an arrow or arrows to represent distance and direction of each object in motion. To organize the information in a chart, that table. Look for times, distances, or rates that are the same. And like in this last one, it was distance. These often can lead to an equation. Translating into a system of equation allows for the use of 2 variables. Make sure you label those variables carefully. Remember what they are defined to be. And always make sure you answer the question asked. See that all the time. You go through a lot of work, a lot of details, get it all right, and then forget to answer the question. So that's the end of Chapter 8 that we're going to cover for this course. And so we'll have a test over just these 3 sections, and or quiz, then a chapter test. So here we go.